Division by zero is possible. I repeat, division by zero is possible. I hate being told that I simply cannot do something. So today, I'm going to prove that not only is it possible to divide by zero, but it is also useful. And I will do this by using nothing more than simple algebra and the laws of mathematics. Firstly, let's discuss why division by zero is considered undefined or not possible. There are several reasons why division by zero is considered taboo within mathematics, and if you have been searching around for inspiration, you may have come across an image like this. In essence, this image is a pretty good representation of what happens when you divide by smaller and smaller numbers. This is a simple example to understand. Simply put, 1 divided by 0.1 is equal to 10, 1 divided by 0.01 is equal to 100, 1 divided by 0.001 is equal to 1,000, so on and so forth, in both positive and negative numbers. Therefore, it is reasonable to assume that 1 divided by 0 is equal to infinity. In fact, it is reasonable to assume that anything divided by 0 is infinity. And since infinity is infinite, then any number divided by 0 is equivalent to each other. Therefore, when you boil it all down, one number can be equal to every number. Another way to look at it is that division is just counting how many of the divisor you can subtract from the dividend to reach 0. One can claim that since 0 has no value, it cannot subtract. Therefore, the solution is infinite without being solved ever. All of these proofs break, however, because they assume that all infinites are equal. What? What do you mean you don't think that all infinites are equal, do you? Seriously? Well, you aren't thinking dimensionally. Yet, but don't worry, I'll help you out. Because of the nature of 0 and the mathematics therein, you're going to have to open up your mind a little bit to a higher dimension. Imagine with me. Imagine a straight line stretching on indefinitely in both directions. This line is one-dimensional, but there are an infinite number of points along this line, stretching from negative infinity to positive infinity. No matter where you look, which section you look at on the line, there's always going to be an infinite amount of points. So that's a lot of points, right? An infinite amount of points. But let's take a look at the second dimension. By taking another line and placing it on top of the first one, now there are two lines stretching on indefinitely. Now there are not only points on the lines, but points between the lines. Are there the same amount of points here as in the last image? Of course not. There are more points. In fact, there are infinitely more points in this image than on the last, no matter where you go. Now, let's take a look at the third dimension. Now, there are infinitely more points on here than the last. Now we have 3 axes to worry about, and the areas within, as well as the volume within. So it goes on forever and ever. Now let's look at the fourth dimension. This is a representation of the fourth dimension. Now we have infinite points in infinite area, in infinite volume, along an infinite line. But this goes on and on and on and on into infinite dimensions. The point that I'm trying to make here is that not all infinites are equal. You can be infinitely long in one dimension, but the second dimension above you is infinitely more infinite. So just believe me when I say that 1 times infinity is not the same number as 2 times infinity. It takes me back to my childhood, that line. With this in mind, just know that x divided by 0 is not equivalent to y divided by 0. unless x is equal to y. So, with this established, let's get on with the math, shall we? Let's do some find x problems. You're all here to figure out how you can divide by 0, and I'm going to show you. So, forgive me for this image, I'm not too good at writing my own formulas. Anyhow, we have the mission to find x, where 5 is equal to the sum of x plus 4 times 0. So to start with, I'm going to distribute the 0 inside the parenthesis to each variable. Then you complete the operations, and then 5 equals 0. Oh dear, this isn't good. That's not how math is supposed to work. 5 absolutely does not equal 0. So, as you can see, using traditional math, we cannot solve what x is because it is forbidden to divide by 0. Traditional math just breaks. However, by just saying, I do what I want with zeros, you can't stop me, we can still follow all the rules of math and come to a rational solution. So with this method, we simply do to 0 what we do to any other number. Distribute the 0 to all of the variables, then divide both sides by 0 to cancel out the multiplication. Now we have 5 divided by 0 is equal to x plus 4. So now we subtract both sides by 4 to isolate the x, and we end up with x equals 5 divided by 0 minus 4. This is where we stop. I will discuss later why we stop here, but for now, math is no good if we can't get to a logical end to the formula, right? So, if we plug in the answer that we got into the equation, the left side must be the same as the right side. This is how you prove an answer in algebra to be correct, right? So, let's go ahead and do that. Let's plug the answer we got back into the equation. So when we plug in 5 divided by 0 minus 4 into x as one number, we come up with 5 equals the sum of 5 divided by 0 minus 4 plus 4 inside parentheses, all multiplied by 0. That's a mouthful. So let's just do the same thing that we did before. Distribute the 0, which will break out the parenthesis. From here, we can either complete the operations or we can divide both sides by 0. Either way, we end up at the same answer, which is 5 equals 5, which is a rational ending. A few things to note. Why did we stop at 5 divided by 0 minus 4? Well, while we can divide by 0, our minds aren't able to comprehend what that means. And before you start chalking all of this up to nonsense, think about this. No, not I as in me, but I as in the square root of -1. Yes, I is an imaginary number. Well, that's an unfortunate name that the mathematicians gave them, but the name doesn't make them any less real. The whole reason that I exists is to find the points on the bottom left quadrant of a circle. Because both coordinates are negative, and the formula requires squaring numbers, the solutions are impossible. But circles exist, don't they? So we adapted math around this problem, and now we have solutions. So whenever someone asks, hey, what's the square root of -25? As if anyone would ask you that in daily life, the answer is, of course, 5i. Well, it's actually 5 times the square root of -1, but I is the symbol of the square root of -1. So what does this have to do with division by 0? Well, in the last image I showed you, you may have noticed that I used the notation 5 sub z on one of the parts. Basically what I have done here is the same thing that we have done with I. the answer to that formula is actually 5 times the product of 1 divided by 0 minus 4. The product of 1 divided by 0, of course, has been relegated to a symbol, sub z, like I is. And just like that, xi squared will undo the root on I to make negative x. And x divided by 0 times 0 will undo the division by 0 to make x. Any number divided by 0 could simply be referred to as the product of that number times 1 divided by 0, and the math can then be applied in the same manner as any other imaginary symbol, like I, pi, or e. So, as you can see, division by 0 is completely possible, as long as you treat it with the correct mentality. That is, a number that humans cannot wrap their minds around. A number that should not exist, but clearly does, in the case of I. So please, stop telling me that I can't do it, because I did. Anyway, this has been some dumb guy on the internet telling you how to do things that you didn't know how to do already. Thanks for watching. If you want to let your friends or teachers know how to do this, go ahead and share it around. This is my theory. I made it completely by myself. It's been a few years in the making. So just, share it if you want. Thumbs up, thumbs down, doesn't matter. Thank you, and have a wonderful day.